So in this question, I'm looking at SEC 2018 Leaving Cert Higher Level Maths Paper 1 Question 5, and it's a sequences and series question. The sieve of Sundaram, I'm sure I'm pronouncing this wrong, is an infinite table of arithmetic sequences. The terms in the first 4 rows and first columns of the table are shown. Find the difference between the sum of the first 45 terms in the first 2 rows. So the first 45 numbers going that way and the first 45 numbers going that way. What's the difference between the two? So here I've written out row 1, here I've written out row 2, and we know it's a arithmetic sequence, so we're going with the linear sequence as well as another way of describing it. We know all we need is our formula that we've laid out. Our A is our first term, our D is our common difference, and we want the first 45 terms, so N is 45. So it's a fairly straightforward question, this. Subbing in, just on this left-hand side, A is 4, and D is 3, and I said we want the first 45 terms. So you're multiplying that out, and on the right hand side, A is 7, the first term. D, the first difference, or the common difference, is 5. We want the first 45 terms. Multiply it out, subtract the 2. Easy question. Find the number which is in the 60th row and the 70th column of the table. So what I do is I go and find, well, I know row 1, row 2, and row 3. So that's going across, okay? So row 1, row 2, and row 3. And I'm looking for the 70th values. So I'm looking for the 70th values going downwards here. So if I can say this is 1, 2, 3, 4, I'm looking for 70. 1, 2, 3, 4, I'm looking for a term 70. 1, 2, 3, 4, I'm looking for term 70. So I find these 3 terms over here in the column, in the 70th column, and then I go and find the 60th term, which would be down here for that column. So of those first 3, what is T70 for the row 1, 2, and 3? So I have row 1, 4, 7, 10, 13, and I go and find T70. Again, from the log tables, we know Tn is equal to A plus N minus 1 times D. So that's all I've done, is use this formula here from our log tables, from sequences and series in our log tables, and I've found the 70th term in the first 3 rows. So the first 3 terms in the column 70 going down are 21, 35, 352, and 493. What is the 60th term? So again, this is like going downwards, 211, 352, 493, and then I want the 60th term of that. So it's again very similar. I need to find the first term, which would be 211. The common difference between these two will be the same as the common difference between these two. It's worth checking. It's 141. And then I'm using Tn is equal to, as I've highlighted up here, because it's an arithmetic or a linear sequence. And you can find T60 then. Next question is an absolute brilliant question. Big fan of it. And it kind of plays in a little bit with complex numbers. So I can show you the whole question. I won't show you the whole question. So the first 2 terms in a sequence are given as A1 is equal to 4 and A2 is equal to 2. The general term is defined by AN is equal to AN minus 1 minus AN minus 2. So you can think of it as, if I want A3, you want to take away you want to have A2 take away A1. So that leads you to getting A3, and we know A2 and we know A1, okay, to get A3. If I want A4, I need to take away A3, Sorry, I want to have A3 take away A2, which gives me A4. If I want A5, I want to have A4 and take away A3, which would give me A5. If I want A6, and this is the point where he runs out of colours, I think. Yeah, if I want A6, I want to have A5 minus A4 and follow the process all the way down to A8. The reason I want A8 is because it says the next 6 terms. Write out the next 6 terms in the sequence. So I've got A1, A2, A3, A4, A5, A6, A7, and A8. And you might notice then that it's a bit of a repeating pattern. 4, 2, 4, 2. It repeats every 6. So it's a cyclical pattern. It repeats every 6 terms. So that means the A2019 is going to be the same as A2013, 2017, 2007. And then I can take away any multiple of 6. Now I've taken away 300 times 6, but you could just stick any number in your calculator. So 300 times 6 gets me down to 207. And then I'm taking away more multiples of 6. Because it repeats itself. The pattern repeats every 6 terms. So I can take away full chunks of 6 until I'm getting down to the single lowest digit, which would be A3, which is the 3rd term. And I'm getting A2019 is minus 2. The reason I say this is similar to complex numbers is because of complex numbers, we know that's cyclical as well. If we're multiplying by I, you're multiplying by I, it repeats every 4. So it is a cyclical sequence or pattern there as well. Marking scheme for it, 10 marks for the first one. Really nice. Like super nice there. 10 marks for the next one. I think that's probably the hardest question on the paper. Not the paper, on the hardest part of this question. 10 marks for that. And obviously 5 marks for the last part. Hopefully you found the video useful anyways.